Dear students, today in this video we will solve section B of the same question paper which we have dealt in the yesterday's video. Section A I have already dealt, sample paper 1. Now today I will solve section B of sample paper 1. Now let's see question number 2. First question, a group of elements in the periodic table is given as beryllium, magnesium, calcium, strontium, barium and radium. Now all of you must know that these are the elements of group 2, that is alkaline earth metals. Now the questions which has been asked from this, you have to answer only the elements from this group only. Number first is, which element has most metallic character? As you all know, down the group metallic character increases. So the number first answer is radium. Which element would be expected to have highest electronegativity? Obviously the element having least metallic character will have highest electronegativity. So the element which is at the top of the group, that is beryllium, will have highest electronegativity. If the EC of beryllium is 2, how many valence electrons are there in calcium? Obviously both belongs to same group, so number of valence electron will be same. So calcium will also have 2 valence electrons. Atomic number of calcium is 20. You have to write the formula of calcium with chlorine. Okay, you have to write the formula of calcium with chlorine. So as you all know that calcium is having valency plus 2 here because of valence electron 2, and chlorine is having valency -1. Simply cross multiply and you will get the formula as CaCl2. Next is, state the metallic nature of the elements in the group to the left of this group in the periodic table and justify your answer. To the left of the group 1 you will have group 1, and group 1 have more metallic nature as compared to group 2 because metallic character decreases across a period. So here you will write metallic character is more of group 1, and because metallic character decreases across a period. Now write the structural formula of pentane to all. How will you draw pentane to all? You have to first pick up the root word, that is pentane. So you have to draw 5 carbon atoms, 1, 2, 3, 4 and 5, and at second carbon atom you have to put OH because OH suffix is all, and now you have to balance all the carbon atoms. So here I will put H3, 3 and 1 H, H2, H2 and H3. So this is pentane to all. Next is acetone. Acetone is the general name of the first member of ketone, that is dimethyl ketone. So acetone is drawn. The first member of ketone has 3 carbon atoms, and the ketone group will be at the center carbon atom, and now you have to balance it with the rest of the carbon atoms with the hydrogen. So this is the structure of acetone, that is dimethyl ketone. Next is dimethyl ether. This is again the general name, dimethyl ether. Same structure, you will have 3 carbon atoms because it is a central group. Ether, not 3 carbon atoms. Here in the center you will have O because ether group is represented by O. In the center it is a central group, so it will be in the center O, and rest of the carbon will be balanced and you will get dimethyl ether. Butanoic acid, 4 carbon atoms, root word is butane, so 4 carbon atoms you have to draw, and the last one we will make it as butanoic acid. COOH correspond to suffix butanoic acid, and the rest of the carbon atoms you have to balance with hydrogen. You can either draw condensed structure or you can also draw the open branched structure, as you wish. Both are correct. Next is ethylene. Ethylene is the general name of ethene. So ethene is the first member of alkene. It is very easy, having 2 carbon atoms. Put 1 double bond and balance it with hydrogen. CH2 double bond CH2. Next is, refer to the flow chart and you have to write all the equations corresponding to the following conversions A, B, C, D. Now this question mostly students do a mistake in the board exams. They don't understand actually what do these letters A, B, C, D represents. A, B, C, D represents 4 complete balanced equations. Okay, don't write any reactant, don't write any product, you have to write the full equation. Now for example, just I am telling you for A. So how will you write in your paper? You will write here A, arrow, and then you can put here double arrow, otherwise you will be confused in equation. A signifies to this equation. Now here one reactant, sodium chloride, is given and one product is given, HCl. So from sodium chloride you have to prepare HCl. So NaCl is reacted with concentrated H2SO4 to give you NaHSO4 plus HCl. Now you have to check whether the equation is balanced or not. This equation is already balanced and it is a valid equation because this is the lab preparation of HCl, as you all know. So this is a conversion in which one reactant and one product has been given to you, and this full equation is termed as A, which signifies the conversion of NaCl into HCl. Now let's come to second conversion. From HCl you have to make ferrous chloride, that is iron 2 chloride. So you will write here B, and then from iron you have to make iron 2 chloride. So you have to react it with HCl. Simple displacement reaction, you will get ferrous chloride plus hydrogen. Again, this equation I have already balanced. Don't leave any equation unbalanced. Next is C. From HCl to ammonium chloride, very easy. HCl, when made to react with ammonia, you will get ammonium chloride. Again, this equation is balanced. Next is hydrogen chloride to lead chloride. So here I will write HCl, when made to react with lead, you will get PbCl2 plus hydrogen. Okay. So these are the 4 conversions A, B, C, D in the given question. Now next, come to the next question, that is complete. To electroplate an article with nickel requires an electrolyte which must be in a solution containing nickel ions. The article to be plated is placed at the cathode of the cell in which plating is carried out. The anode of the cell is made from pure nickel. The ions which are attracted to the negative electrode and are discharged are called anions. Okay, so if you know the process well, then you can write the appropriate correct keywords in these filling the blanks. Name the functional group OH. OH is termed as hydroxyl group. State the color of the following salts. Copper nitrate is blue in color, lead nitrate is white or colorless, you can write. Ferric chloride is reddish brown in color, manganese dioxide is black in color, and lead sulfide is again black in color. Complete the following table. You have been given the aqueous solution of these 5 salts, and you have to write the color of the precipitate when NH4OH is added and when in excess, and what will be the nature of the precipitate. So number 1, zinc sulfate. Here A will be gelatinous white precipitate, lead nitrate chalky white precipitate, ferrous sulfate dirty green precipitate will be formed, ferric chloride reddish brown precipitate will be formed, copper sulfate pale blue precipitate will be formed. And what will be the nature of the precipitate on adding excess ammonium hydroxide? Zinc hydroxide will be soluble, lead hydroxide will be insoluble, ferrous insoluble, ferric insoluble, and copper will be soluble, forming a deep blue solution. So you have to mention the solubility apart from the color of the precipitate. You have to learn both ammonium hydroxide and NaOH. Any one can be asked in the paper, even in observation or equation based questions. They can ask you any one of the following. Complete, balance and identify the oxidation and reduction reactions. Now let's see how to solve this question. Number first is Cl negative dash will give you chlorine. So first we'll balance it and fill the appropriate number of electrons here. Here you have 2 Cl, so we'll put 2 here. Now 2 electrons are involved, so we'll put here 2 electrons, and negative charge is decreasing. It means from -2 to 0. It means definitely there will be a loss of electron, and loss of electron is termed as oxidation. Next is hydrogen 2H positive, and the blank is on the left side. Hydrogen blank, and will give you H positive. Again balance it. We'll put 2 here to balance the number of atoms. Again 2 electrons are involved, 2 positive, so 2 electrons are involved. There is an increase in positive charge. Increase in positive charge means there is a deficiency of electrons. So definitely there will be a loss of electron, and this is again termed as oxidation. Next is 2 Fe2 positive, 2 Fe3 positive, and here the blank has been made. Now let's see first. Already the atoms balanced. Let's see the number of electrons involved. 3 to the 6 and 2 to the 4. 6 minus 4 is 2 electrons. So 2 electrons are involved here, and positive charge is increasing. Again, that is oxidation. Oxidation means minus here on the left side, and here it will come as positive, but the result will be only oxidation. So this is again oxidation reaction. Next is 4 oxygen will give you O2 negative dash. Now here number of atoms, 4 to the 8, so we'll write here 8. Number of electrons involved is 16, 8 to the 16 electrons. Here the negative charge is increasing. Increasing means that is reduction. Reduction means positive on the left side and minus on the right side, that is reduction. And the last one is Ca2 positive to give you 4 Ca. Again atom first you balance 4, so we'll write 4 here. 4 to the 8, 8 electrons are involved. Positive is decreasing means reduction. Reduction means you have to put positive here, and this is reduction. Okay, so this is the question in which you have to complete balance and identify whether the reactions are oxidation or reduction reactions. Next is a diagrammatic question. Funnel arrangement clearly indicated by the diagram which you have read in HCl and ammonia both. Now because here HCl is mentioned, so obviously the gas will be here HCl gas. Give the name of the gas A, that is HCl gas. Why is funnel arrangement used? To prevent the back suction of the water into the delivery tube. And at which temperature HCl form constant boiling mixture, that is 109.8 degrees Celsius, and somewhere on the net it has been written 108.5 degrees Celsius, and in some books it is written 109.8 degrees Celsius. So you can write whatever has been written in your textbooks. That will be a much better option. Next is write the general formula of alkenes and alkynes. General formula of alkene and alkyne, that is a theoretical question. General formula of alkene is CnH2n, and general formula of alkyne is CnH2n minus 2. Write it in proper subscript and superscript. Sometimes children write these n and 2n just beside C and H, so that will be considered wrong. So please write it in appropriate notation. Next is choose the most appropriate answer from the following. You have been given some options and you have to find the answers of these 4 questions from it. An acidic salt. An acidic salt obviously will have one H. So this is the acidic salt, that is NaHSO4. An insoluble chloride. Only 2 chlorides are given. NaCl, which is soluble. AgCl, which is insoluble. So that is AgCl. On treating with concentrated H2SO4, the salt changes from blue to white. So find out a blue salt, that is only blue vitriol, which changes to white on heating or on treating it with a dehydrating agent. So third answer is copper sulfate 0.5 water. On heating, the salt changes from green to black. So green salt is only one here, that is copper carbonate, which on heating will give you copper oxide, which is black in color. Now next question is draw the isomers of butane, chain isomers, butene, position isomers, and butene again stereoisomers. In 2023, the stereoisomerism is not in your course. Okay, so chain isomer, let's draw butane. Chain isomers, you can draw only 2 chain isomers of butane. That is, one arrangement is this, and another arrangement with IUPAC name is not repeated is this. Just balance it with hydrogen, H3, H2, H2, H3. This is one isomer, that is N-butane, and this is the second isomer, that is 2-methyl propane, or you can also say it isobutane, which is the general name. These are the only 2 chain isomers formed from butane. Next is 2 position isomers from butene. Butene we can have only 2 position isomers. First butene is like this, you can draw double bond at first position, and another butene we can draw double bond at second position. So now just you have to balance it again. So this is the first 1-butene, first isomer, and this is the second isomer, that is 2-butene. Write the names along with the isomers. And number 3rd is stereoisomerism. Although we can draw it, but because this is not in your course, so if you have not read, then there is no issue. But if you have read, then you can also draw the 2 isomers of stereoisomers of butene, that is like this. It has cis and trans isomers. If the same groups are on the similar side of the double bond, then it is cis butene, and if they are on the opposite side of the double bond, then it will be termed as trans butene. Okay, this is cis butene having methyl group on same side of the double bond, and this is trans butene having same group on the opposite side of the double bond. Next is write the electronic equations, ionic equations at cathode and anode for the following. Number 1st is acidified water electrolyzed between platinum electrodes. So let's see here for acidified water at cathode and at anode. You can also write the complete equation also. Water will dissociate into H positive and OH negative ion, and sulfuric acid will dissociate into 2H positive and SO4 2 negative ions, because pure water is a bad conductor of electricity, so we add sulfuric acid in it, as you all know. Now at cathode only one cation is there, H positive, so H positive will migrate here. It will accept 1 electron and will convert into H. Now 4H will give you 2 hydrogen molecules. Next is, out of both these, OH negative is down in the electrochemical series, so at anode OH negative will be discharged. It will lose an electron to give you OH, but OH means nothing, so it will be multiplied by 4 and will give you a product, that is oxygen. So you have to write both the equations, and you have to show that there are 2 molecules of hydrogen and 1 molecule of oxygen is evolved, because in water the ratio of hydrogen and oxygen by volume is 2:1. Next is molten NaCl between carbon electrodes. NaCl molten means there is no water, so only you will dissociate NaCl into Na positive and Cl negative. At cathode, cation will migrate, at anode anion will migrate. Na positive, it will accept an electron to give you sodium, and here Cl negative will be discharged, which will lose an electron to give you Cl, but Cl means nothing, so Cl plus Cl, you will get chlorine gas here. Now if you want to balance the electron, you can put simply here 2, 2 and 2. Next is aqueous copper sulfate with copper electrodes, that is active electrode. So copper sulfate will dissociate into copper ions and sulfate ions along with aqueous solution, so water will be there, dissociate it into H positive and OH negative ions. At cathode, you will have copper, because it is down in the electrochemical series, it will accept 2 electron and give you copper metal, brownish pink metal at cathode. And at anode, because it is active metal, so both these ions will migrate to anode, but no one will be discharged, and active copper will participate in the reaction and will lose electron to give you copper ions. So these are the equations for copper electrolysis with copper electrodes. Extraction of calcium from calcium chloride. Calcium chloride, again you dissociate, that is electrometallurgy, so dissociate into calcium ions and chloride ions. Calcium will migrate to cathode, accept 2 electrons and give you calcium, and at anode chlorine ions will migrate, lose 2 electrons and will give you chlorine gas. Okay, so this is the formation of calcium and chlorine gas at cathode and anode respectively. Next is electrolysis of molten lead bromide with inert electrodes. So molten lead bromide, no water will be there. Lead bromide will dissociate into lead ions and bromine ions at cathode. Lead will be discharged except 2 electrons and will give you gray metal, that is lead. And at anode, bromine ions will be oxidized to give you bromine gas, that is reddish brown gas. Fresh milk has a pH of 6, that is acidic. Milk is slightly acidic, and when it changes to curd, it means lactose changes to lactic acid, and therefore obviously the pH value will decrease further because of the formation of lactic acid from the lactose by the action of certain anaerobic bacteria. In which medium pink color phenolphthalein is noticed, that is alkaline medium. Give one example of each of weak mineral acid. One example is carbonic acid, H2CO3, and triacetic base you can write ferric hydroxide, aluminium hydroxide. All these both are triacetic base because they have 3 hydroxyl group per molecule of the base. In aqueous solution they give you 3 molecules of hydroxyl ion. Okay, so this is the section B of sample paper 1. In the next video we will deal with certain MCQ questions from different chapters. Thank you.